So hello everyone, welcome to the new section of the course. And in this particular section, we are going to cover all of the concepts that fall under this topic, that is working of JFET. Okay, but before coming to this particular topic, we need to first consider one type of JFET, and then we need to understand its working. Right? Either we need to go with N channel JFET, or else we need to go with P channel JFET. Okay, so in this particular session, we are going to see that uh, like why exactly the N channel JFET is preferred over P channel. There are certain reasons for it. We will discuss each and every reason step by step in detailed way, and then we will conclude that how exactly N channel JFET is better than P channel JFET. Okay, so this is the agenda of today's session. Okay, so uh, as you can see, I had written over here that we always prefer N channel JFET over P channel because of the following reasons, and these are the four such reasons which you are seeing on your screen. So the first reason is that since in N channel JFET the P type material is doped in N type, and N type has electrons as the majority charge carriers. Okay, so just focus on this particular part. If this is the N type material, okay, in N type material I'm doping a P type, right? I'm doping P type material. Okay, this we had seen in the construction of JFET in the previous session only, but still just for your revision purpose I'm taking this point. Okay, so this is the N type region and this is the P type region. Okay, this is the P type material or P type region. Okay, and we all know in N type region there are the majority charge carriers are electrons. Okay, so the electrons are present everywhere in the N type material. Okay, so this is the meaning of the very first line. The meaning of the second line is that, see, we will go with the second point, that is electrons are lighter in weight as compared to holes. Okay, if you know the mass of electrons, just if you don't know, just search on Google, and if you also search the mass of holes, okay, and try to compare it, and then you will understand the meaning of this second line. Okay, so I'm not explaining this particular second line, just it's like, you are comparing one heavy ball and the one ball whose weight is quite less, so it's something like that. Okay, so just find out the mass of the electrons and holes, then you yourself will come to know that how exactly electrons is lighter in weight as compared to holes. Okay, the third point is, in general the flow of current is because of electrons. Okay, so this particular point we had discussed in our course 1. So if you could remember, in course 1 I told you that if electrons is moving in this direction, so the current will always flow in the opposite direction of electron. Okay, on contrary, if electrons is moving in this direction, so current will move in opposite direction to that of electrons. Okay, now we will see in case of N channel JFET where exactly the electron moves. Okay, and if electron moves in that direction, then like if electron moves in X direction, okay, so current will move in the exactly opposite direction of it. Okay, so this we had discussed in the course 1. Okay, so remember this thing, in N channel JFET we have majority charge carrier as electrons, and the moment I say that N channel JFET has majority charge carriers as electrons, okay, that means what? That means the current in N channel will flow because of uh, electrons only. So generation of current in N channel is because of N channel JFET is because of electrons only. Okay, so just remember this particular point. Current is generated in N channel JFET because of electrons. Okay, because of movement of electrons. Okay, now we will come to the fourth point, that is in P channel JFET the current flows because of holes. Okay, so in case of P channel JFET, if you could remember, over here you will get N type material. Okay, in both of these on both of these sides, and in between you have P type material. Okay, so P type material has what? Holes, excessive amount of holes. Okay, and the current flows because of these holes only. Okay, so just remember this particular point. In P channel JFET the current flows because of holes, and in N channel JFET the current flows or the current is generated because of electrons. Okay, great. Let me erase this particular point. And there might be few students who had directly enrolled in the course, they might be not having that idea about the semiconductor. So yeah, and even those students who know me, I mean who are following my courses, so they are very much aware with semiconductors and all, but still if I explain this particular point, this will act as a revision to them, and those students who are new, who are directly enrolled in this course, so that will act as a foundation or basic understanding to them. Okay, so let me explain you this particular thing. Holes are like hypothetical. Holes is like a hypothetical concept. Okay, hole is like a hypothetical concept. Hypothetical concept. Okay, hypothetical concept. This we had discussed in the semiconductor course as well, that means in my course too. Okay, so generally you will find holes in p-type material or p-type region, whatever you say, in p-type material. Okay, and we all know p-type is made up of trivalent impurity. Trivalent impurity. If you could remember the silicon bond, right? Silicon and the I don't remember, I think arsenide, I don't remember the other atom, but if you could remember, we had done this, that is silicon, and then it was sharing 4 covalent bonds, right? Something like this, if you could remember in the course 4. Okay, and in which case I will not go in that depth because we had already dealt in the course 4th. Okay, so impurity. So one electron was like one electron was less. Okay, that means the 4th bond was vacant. Okay, there wasn't any electron in that 4th covalent bond, if you could remember. Okay, so one electron was less, okay, in that 4 covalent bond. Okay, so over here in trivalent impurity, one electron was less. Okay, one electron was less. Okay, in case of electron, let me write over here, in case of electron, first of all, it is not a hypothetical concept. Current flows because of electron only. So electrons are present in n-type material or in n-type region. Okay, electrons are present in, just a second, electrons are present in n-type material or in n-type region, whatever you say. Okay, and basically n-type material or the n-type impurity, n-type region, it is made up of pentavalent impurity. Pentavalent impurity. So if you could remember that we were getting one electron more. Okay, so like the silicon atom was sharing the 4 covalent bond with its neighboring atom. Okay, but at the same time we were getting one more extra electron. Okay, so if you could recall that particular concept, so we were getting one electron extra. Okay, one electron more, or one electron is more in case of n-type. Okay, and if you try to compare these two, although we had also deal with this particular concept in bipolar junction transistor as well in my, I think, course 4th, right? So there also I explained you that why exactly we go with NPN transistor over PNP. The reason was almost similar to this only. In fact, it was 99% similar. This was because of this reason only, because a p-type material has less electron. As you can see over here, one electron was less. Okay, if the silicon is sharing 4 covalent bond with its neighboring atom. On contrary, in case of n-type material, or in case of n-type impurity, or n-type region, we have pentavalent impurity, or we have pentavalent electrons. So that means 5 electrons are available. So 4 will share 4 will be focusing on the covalent bond, and we are getting one more extra electron, right? So that electron it is almost readily available in the conduction band, if you could try to recall that particular concept. Okay, so from here what you can conclude is that p-type has less number of electrons. Okay, so the current generated or the flow of current would be very less as compared to the n-type. On contrary, in n-type, if you could see, we have more number of electrons. Okay, and if we have more number of electrons, then the current generation of current would be quick, and the flow of current would also be faster. Okay, so that's why we always prefer n-type JFET over p-type, because in n-type the majority charge carriers are electrons, and in n-type the electrons are in excessive number, right? They are excessive as compared to p-type. Okay, and they are also lighter in weight, so they can travel very quickly, and if they are traveling very quickly, so the generation of current would be fast and the flow of current would also be very quick. Okay, so this was the reason behind going with N channel JFET. Okay, and this was the same reason that why we preferred NPN over PNP as well, and the same will be applied in case of N MOSFET and P MOSFET as well, that we will see in the upcoming courses. You need not worry about that, but the reason is same for all the all the transistor, why we preferred N type over P type. Okay, in case of BJT it was NPN, in case of JFET it is N channel JFET. Okay, so I really hope that you understood this particular concept, that why we prefer N channel JFET over P channel JFET. Okay, so in the next session or in next video, we will focus on the working of JFET, and there I will just consider N channel JFET. So for P channel JFET, it's like homework to you all guys. You do it on your own. If you face any difficulty in it, feel free to ask me at any time. Okay, so thank you for listening patiently. I am ending this video over here. Thank you.